right, Francisco, let's start by introducing our audience to yourself as well as to Cortical.io.
Yes, hello. I'm Francisco Webber. I'm one of the founders and the CEO of the company Cortical.io, which is a startup originating from Vienna, Austria. And we are working in the domain of natural language understanding and have developed our own technology for doing so and for rendering text information. And based on that technology, we are offering a certain number of technologies and technical platforms to the market. We have been starting very early, sort of, for a startup. It might sound a long time, which is 2011. But believe me, setting up sort of a company that creates the technology beneath the product itself takes a little time, obviously.
So, Francisco, I think the best thing would be if you could do kind of like a historical overview, brief, but this historical overview of the natural language processing trajectory. What is the prior art and where are you innovating? What is the approach that you bring to the table that is unique and differentiated?
Yeah, so in this context, my background is from a domain that previously, in the old times of the years 2000, the early years 2000, was called information retrieval. So it's basically the technology behind search engines and zipping through a lot of text data. And what I've learned and practiced there basically is what I would summarize under statistical modeling, basically. So starting with pretty easy ways of sampling the data that we want to work with, which in the easiest, simplest case would be counting the occurrence of words in a document and in a collection. And on one hand, it is fascinating to see that that approach actually delivers a certain amount of results and a certain quality of those results. But by working a lot in the domain, I realized very early that that is not the sort of solution to the problem that we need to compute with language data, with the meaning of language data. And in the year 2005, I became for the first time aware of the research of a Californian brain researcher, Jeff Hawkins. You might know him from the Silicon Valley times, sort of. And what made him so interesting is that he came up with a computational theory of the human neocortex. So, and that was to me the first time I encountered someone actually talking in theoretical terms about the brain. And the theory he had built so far, so that's an ongoing project, was extremely impressive to me because it could actually explain a lot of brain phenomena that we know of and where we didn't actually know how they could be mapped. And I took that theory basically saying like, okay, if Jeff is right with his theory, what does this mean for language? And that basically sets the proper, I would say, constraints to the problem to actually guide me to a solution, I would say for now, which turned out to be a non-statistical way of rendering the representation of language elements. And with that sort of fundamental step of finding a way in rendering the information differently, it turned out that many problems you typically have, like disambiguating language, for example, finding out that organ can either be a part of your body or a musical instrument, that is very computationally intensive if you need to do this purely on statistics. but it becomes like a side effect if you choose the representation of text in what we today call semantic fingerprints, where that becomes sort of a trivial Boolean operation, basically to discriminate those two cases. So basically with that discovery, we were lucky enough to get some research funding in Austria to basically build a prototype with commercial intention behind it. And we could, within a half a year, already demonstrate that many traditional statistical modeling features were available on that platform too, but at a very easy sort of and efficient way in the implementation, and with an astonishing degree of sort of resistance to noise and all these features that you would normally expect in the brain. Yeah? So missing data, noise in the data is close to no problem for the way how we work with this data compared to statistical systems.
So,
yeah.
Francisco, let me interrupt you for a second, and let me try to understand the technology a bit better. I understand I understand completely the statistical approach versus more of a semantic modeling approach. How do you start? So let's say you get a data set. How does this begin?
Yeah, so the one big problem that we have in statistical representations is that we lack something like semantic grounding. So there is no fundamental ground truth to which we can tie the features and properties of what we want to represent. And in our approach, we basically model what the brain does by the continuous saving of all the experiences. Yeah, so since your moment of birth, basically every experience that you had got stored in the neocortex, let's say, in sort of an associated method, where you end up with a large pattern that basically has the weight set to what your model of reality is. And we were able to sort of synthetically produce that semantic space, as we call it, by ingesting reference information. So contrary to the statistical method that tries to train a model based on the actual payload data, so the data you want to work with, we train the model based on the same things that humans do. We take textbooks, encyclopedias, reference works. They get compiled into sort of the language level ground truth for a specific use case, for example. So you want to create a system that understands medical prescriptions. So we don't train it on medical prescriptions, but we train it on textbooks and medicine. Okay. That's the first step. And once we have that sort of world knowledge in the system and have it become the standard to all the representations, we generate for every word or every sentence or every paragraph or every document, we generate a binary representation which corresponds to the distribution of topics according to our grand truth map. And that happens sort of fully automatically. And that arrangement of that map is computed, and that's the only machine learning part at that level. That map is actually of the sort that two items that are similar in their meaning, so for example, sports car and the word Ferrari, if you render the fingerprints of both of them, you will see that, for example, 60% of their features overlap. Means they have, for 60%, they have the same features, so they have a big overlap, indicating that these two words are similar, at least in the context where they overlap, which I can also inspect. Yeah? And this is done by a simple overlap measure, which is sort of with a Boolean comparison. It's sort of the fastest thing you could possibly do on a microprocessor. So as you can imagine, that is very fast. So I can do 500,000 of those comparisons per second on my laptop. So it's a very performant way to actually do at least medium-level depth semantics on text. And that is what turned out to be, so initially, of course, when you go into machine learning, especially with text, it's all about accuracy, precision, recall, those measures. And that was a decision that we made very early on, is that we could not and wanted not to engage into the, let's say, more academic benchmarking and comparing with other approaches and so on. We were set up to be a company, and we said, okay, we need to prove the meaningfulness of our technology with actual use cases, and we have to go out there and just try fix someone's problems with our technology. And there we were lucky enough to have quite some interest from a number of very early adopters. So that was in the year 2016, where a very large New York bank came to us and said, okay, we have these number of use cases, and we have tried all of the big players in the sector, and none of them could actually provide us with a good way of doing this. A good way always means, when you speak about sort of large-scale text work, with as little as possible human intervention, because that's basically what takes time and what costs a lot of money. And so, for example, a use case was to ingest some 100,000 credit agreements and find out which of them are not complying with the current sort of compliance requirements from the regulator. So if you have no sort of machinery, you have to get a couple of hundred attorneys and have them read through it and make them sort of tag sectors of certain documents where there might be an issue. And the goal was to basically generate a system that could be easily trained in doing this, and then could be applied with a very small footprint to a collection of 100,000 documents. And that was basically what we did, and we took the advantage that our semantic representation has a much higher semantic payload in it than a simple statistical sort of sampling would have. And it turned out that if we trained things like LSTMs, for example, with the fingerprint representation, we need orders of magnitude less training data to do so, which in the end translates to a situation where we could ask a person, for example, to hand annotate something like 50 documents, and the system could already pick up the characteristics, so the typical content, the position, the typical context where a paragraph containing this would appear, that we could demonstrate that with at least 50 and then with 100 examples, the system could be trained to perform even better than a human would, especially if the human would have to annotate 100,000 documents, there's a whole other problematic situation. And so that was like one of some 10 use cases we were confronted there. And they decided to license the technology, as sort of crude as it was at the time, to continue experimenting with it. And so came a bunch of other large players who allowed us basically to work on very specific commercial use cases in the domain of finance, in the domain of petrochemistry, for example, or car manufacturing. So that was something that we saw very quickly. There was no obvious sort of vertical domain in business terms where what we have would apply. It was rather the kind of use case that became sort of the vertical. Yeah, so we found
What were the big use cases? Besides, you mentioned one in this bank. What other use cases were recurring in your teams?
Yeah, so in the end, by doing these practical sort of pioneer work, if you want, we ended up with the use case of extracting information from contracts or from documents in more general form. A second, meanwhile, product is for fast text data, which means messages, goes from tweets to mails to social media posts, stuff that comes in at a very high frequency with a typically rather poor language, but still you want to find out, are people complying to the site rules, or are people complaining on the customer service lines about a certain product, and so on. So this is message intelligence, we call this today, a system that allows you to specify by example. Yeah. So here are 50 examples of emails, how people complain with us. If you ever see something like that, send it to that the complaint desk, for example. Yeah? And these things, the problem there is you can, to some degree, also do this statistically. I say to some degree because there are, as far as I know, no really strong systems out there, but theoretically you could. The problem is that every single filter you implement can cost you the price of a couple of business servers per month to just run that one classifier at the required speed. So we found out that actually what was sort of the blocking situation in the market was the price per filter that you have. If you could drop actually the price per filter to a couple of cents, suddenly people who do have in large enterprises hundreds of those filters, who need hundreds of those filters, could suddenly start thinking about actually doing it. Yeah? And the third component that we offer as a product is a search system that you can imagine that fundamentally like Elasticsearch, for example, but it's not using statistics to actually index the data. It uses, again, the semantic representation. And you can do things, for example, like typing in an English query into a Spanish collection of documents, and you will still find precisely what you look for. Because one aspect is, for example, that the semantic representation is independent of the actual language. It's only dependent of the meaning of whatever has been expressed in that language. So these are the three sort of products that we offer, and we find ourselves with each of those products in many different business areas, sort of where this can become useful.
Let me ask you a few different questions that come to mind as I'm listening to you. Firstly, you said a New York bank came to you, a large New York bank came to you. What does that mean? How did they know about you, or how did that happen? I mean, a large New York bank doesn't come to a random company, right?
Absolutely. Very good question. So, in fact, they had a team that was supposed to be their spearhead in AI technologies. And so they had a bunch of sort of experts who were scanning the market. And at the time, we were a tiny little company, far away in Austria. So the only way for us to reach out was basically me buying one around the world ticket after the other, and doing little things like meetups and small, sort of small scale conference presentations and things like that, and just explain literally. I mean, at that time, we had no product in the classical sense. I simply explained in more detail than I can do now in this interview how the system works, basically. And it has such a intuitive simplicity so that even business people could So they told me afterwards, it's completely logic that this works. This has to work. That's the kind of...
So somebody from that bank's artificial intelligence research group heard you speak at a conference or something like that?
Exactly.
Got it.
Exactly.
Yeah. Okay. And
but I have to say they were looking for this. Yeah. So it was not by chance. They were looking for this. Yeah.
Right. Yeah. Now, so your other customers also, similar kinds of things happen? There were groups of people looking for this kind of technology and they were coming to you, or did you do something else to get these other customers?
Well, we then have also grown our then still smallish marketing activities, and so we step by step got the attention at certain events, and so from people working in large companies and going to those events about AI, about all surrounding big data. It was very much called in 2016. And so I presented at all possible events. We made articles in newspapers and so on. And for that, we got individual people from large companies who were precisely seeking. And those were mostly the early adopters. I mean, they have been seeking for AI technologies on themselves already.
Right.
And mostly they have done because they have very specific high pressures in certain areas.
Yes,
that
use
they
cases
already
that
knew
we
by
want
then.
to solve with AI. Yep. Absolutely.
Yeah. And then what they did is, of course, the first thing was to try out all the big providers. But the problem there was that some of those big providers, Google and so on, they rather provide a base technology, and you still need someone who knows to implement this, and you need someone who knows to properly analyze the use case. So what most of those companies did was sort of slow and large projects, but I think it was crucial for them to just learn how this is done. Nobody exactly knew at the time how this worked. So very explorative situation, and our setup, being a small, agile tech team, was quite convenient, and we could sort of win a number of those use cases by just being the only ones being actually able to solve it, for example. Because all the others had at some point to give up because you would have had to, for example, enter 20,000 product names and descriptions in an ontology. So we don't need that kind of work. We do that sort of automatically, basically.
Yeah. Okay, cool. Now, besides the use cases that you have productized, are you also opening up your platform to other developers to build use cases on top of your technology?
Absolutely. That's I would say that's the whole idea behind all of this. So our current strategy in building, on the one hand, bridgeheads into certain markets is one aspect, because especially for a controversial, let's say, technology like ours, so we are definitely not using standard ways of doing things. It becomes even more important to prove that we have some traction as a company. So people are paying money for getting this. That's one proof you need to provide. The other is, of course, fundamentally our product is completely agnostic of a specific business area. As long as the business value is formulated in text, it should be applicable. So of course we built our stuff in a way that we ended up having a platform. That's, in fact, we do already have a platform, but a platform to be used by a community of developers needs more than just a technical platform. It also needs kind of an engine around it to make sure that people can really have an easy access and easy trying it out. So in a near time in future, it's planned to open this up, because of course we will definitely never be able to cater all use cases that would be a match out there.
Right.
And I think,
no, this is everything I've listened to so far, it seems like this company needs to be scaled as a platform as a service company more than a pure solution company.
Absolutely. Interestingly enough, a big group in the in the community of people who are doing this, namely investors, many of them prefer you, especially in an A round or in a rather early round, to show focus. Yeah. So absolutely. So it's a bit of a problematic situation when.
No, it's not problematic. I think it's the way these platform as a service companies typically get built with one type of solution built on the platform, and then later you open it up for other use cases and other types of products to developers. So it's very common. It has become the proven way to go to market for a platform as a service company. But I think you have a much bigger potential than within a specific vertical or a specific use case.
Yeah, I mean, as I said, as we actually tackle the problem at the very fundamental level, we also have the advantage that, therefore, it fits all the dependent use cases. Yeah, so extracting specific information from a document, it was an obvious case with contracts documents, but it can also be, I don't know, any other kind of document, scientific documentation, for example, or medical study reports, you name it. So currently, most of the interest that we see comes from insurance companies and banks, and to me that makes a lot of sense. All their products and all their business interaction is based on language. Yeah, so the product is basically a description of a statistical insurance model that they have.
Yeah, and it's like product. Huge piles and piles and piles of documents and
absolutely.
Contracts
and every transaction is like five contracts and addenda and I don't know what. Same thing is, for example, with the very large companies, and we just got a customer there in Europe. I can even name them. It's Siemens, where companies of that size, I mean, they have literally like 300,000 employees. So you can imagine the documentation behind the business engine with so many people is so large. So they have millions and millions and millions of documents, of course. And the problem in such a situation is that all of these documents talk about and use the language mostly that is relevant to their business domain. So it will all be about, engineering and technical projects and stuff like that. The problem that you get with this is that a word like, I don't know, transducer becomes a stop word in their world because every, 100 document contains that stop word. Yeah? So the problem is that the discriminability, dividing apart two documents on a statistical level is very hard. So there is even some science saying it's impossible at that scale. So the traditional full text indexing works well as long as you stay below, let's say, 2-3 million documents. Yeah, but once you are in the 50 million document space, there might be something like 25% of the documents that are not selectable by any query you could post. Yeah? So that's and the only way out of this is that you not only take into account the presence of certain words, but you take into account the patterns of meanings that are behind, because that's exactly what humans would differentiate the documents. Yeah?
Right. All right. And I understand. I understand all of these very well, and I understand the impact of it. Let me ask you a few slightly different kinds of questions. Firstly, how did you build the business? So you started in 2011. You started to develop the technology around 2016. You got your first major bank customer. What's the trajectory? And between 2011 and 2016, how did you finance the company?
We basically mostly financed it with an angel investor on one hand. So we also were non-typical on our investment path. So we started with an angel investor who, as we went on, got also more and more fascinated about the potential and sort of become an investor. And so he continued investing. And the other end of the revenue scale was basically selling our services, where we were using our then library to solve certain use cases. Not all of them were production grade, so some of them were just the companies wanted to do some exploration to see on a small scale how whatever the automation of some inbound mail, how well it would work. Yeah. And basically there we got maybe in a mix of I would say maybe 70 to 30. So 70% was revenue from service, from work, basically, and 30% were sort of development licenses that we gave to AI teams at those companies, and they kept playing with it further. And then we had a number of 3 or 4 systems who were actually built for production. And yeah, so that basically allowed us to slowly grow to the size of about 33 people we are today, which is still super tiny. But on the other hand, what it also shows is we can handle 4 or 5 customers concurrently with that team, thanks to the efficiency of our approach. Yeah.
So it's a combination of some angel financing, a lot of bootstrapping using services, and then now you are at a point where you also have production-grade product systems.
Absolutely. So the big sort of pivot was in 2019 when we decided that our current frameworks were stable enough and mature enough to actually boil them down into specific products. And we were also lucky to get an investment round with a company called Xilinx. You probably know that's a whole other sort of arm of this, because it turns out that using FPGA hardware, we can speed up our algorithms, which are already pretty fast, but we can speed them up a number of orders of magnitude further. Yeah, so
really?
as I said in the beginning,
I hadn't thought about that. Okay, yes, of course.
Yeah.
So Xilinx invested in the company.
Yeah, and so we were lucky enough to convince Xilinx that it made sense to develop designs on FPGAs who actually speed up our, for example, the mail filter. Yeah, I mean, on software, I can run on a business server. I can run, I don't know, 1 million mails per day through it easily. But what if the same application would be used at the data center of a telco provider, and they need to run 1 billion emails through? Yeah. So then the cost per filter becomes very relevant, and then having a specialized hardware there, and that's, by the way, a trend you can observe anyway on the AI market currently, that people are trying to find a more efficient hardware because things started to get expensive.
Yes, definitely.
To pay 10 million for a GPT-3 model, it's not everybody's size of shoes. Yeah?
Right.
So it turned out by accident, sort of, that we bet on a good horse there, and we created a product prototype for our filter system as a complete appliance, where you would basically get a 1U system. We partnered with Supermicro for that, and basically can deploy that functionality also on an accelerated fashion. As we are not yet with the very big accounts there, it hasn't become a burning thing, but it's definitely something where on the midterm, I mean, just think of hate speech detection for Facebook. Yeah, I mean, just imagine how much computing power they would need to find out the subtle hate speech that could occur in like 90 languages.
So Facebook doesn't have any of this kind of technology?
No, I mean, that was another lesson I've learned very early. In the very beginnings of our technology, I went, of course, and knocked on all the doors of Google and Apple and Facebook and Twitter and so on. But what I had to see is that at that point, they were not waiting for a little company from Austria to offer them something substantial. Yeah, so it's super hard to basically even trigger some awareness. I mean, I remember I met people at product manager at Twitter at the time, and they were desperately looking for a business model. Yeah, and I said, look, I mean, it's just an idea I had, but what if you could provide business customers personalized feeds of your fire hose only with tweets that are relevant to their, so I don't know, provide to Nokia every tweet that is about mobile phones so that they can do analytics on it or whatever. Yeah, if you try to do this with state-of-the-art, pretty expensive. Yeah, even for a company like Nokia to do this with 20,000 messages a second, you need to be, you need to have a strong system to do this. And I could and probably still can demonstrate that I can run a fire hose filter on my notebook using our approach. Yeah. But again, as we were not well known, well established, and so on, it was close to impossible to get some sort of deeper attention. And my belief is the more commercial success we show, and I see this happening
it's a matter
right
of
now.
building credibility.
Yeah,
Francisco, what is the total amount of financing you've put in so far?
So currently we are where we are with roughly 14,000 euros, 14 million euros.
14 million euros, okay.
Yeah, so as you can see, a pretty lean,
very lean, yeah.
First phase.
And your full team, the 33 people, are all in Vienna?
No, so we have our development team is in Vienna. We have a customer success team in New York because our earliest large customers were sort of East Coast U.S. customers. And part of our management is on the West Coast. So we are sort of scattered between Europe and U.S.
America. Okay, got it. Now, what is the two questions I have actually. One is about whom do you see in deals? When you're trying to do these large deals with large customers, who else is showing up in those deals? What other alternatives are these customers considering?
On the side, you mean competitive, in competitive terms?
Yes, competitive, yeah.
Yeah, so as I said, most of our activities are currently in the field around sort of intelligent documents and intelligent message processes. And so interestingly, in the beginning, we saw a lot of the, IBM Watsons and Microsoft Lewis and those kind of systems to appear there. Nowadays, it's mostly companies who have very specific solutions. Yeah? So if we battle for a customer complaint filtering system, we find ourselves next to companies who just produce that customer complaint functionality. We have typically the advantage that we are quicker in bootstrapping a solution than traditional systems are in configuring it. And we have a second big advantage is we are not bound to a certain model. In fact, the user, even the subject matter expert, not even a technical user, at the customer can create his model. So that becomes important, especially for enterprises who are sort of a bit matured because they know that it's a lot of effort normally to train a model. And once you have done the effort, you want to own it. But a company that actually licenses you a pre-computed model, they never have you own the model. Yeah.
Right.
So
the model can be a competitive advantage. So the fact that you allow people to develop their own models is a big competitive advantage for customers.
Absolutely. And now, it's a more systematic way of sort of step-by-step digitizing all sorts of processes in the enterprise.
Yeah.
And maybe one footnote is, of course, in the very recent times, we find often companies from the RPA sector basically try and compete at that. Exactly. Yeah. But they are specialized more in the sort of robot part and less in the actual sort of understanding part of the actual message. So they tend to have weaknesses there too. Yeah.
Mm-hmm. Now, talk to me a little bit about the data infrastructure that you're drawing from. So when you get like these fire hoses of tweets and stuff, what kind of databases are you encountering? Are we talking about Snowflake? Are we talking about Cassandra? What are we seeing in the bottom?
Well, we typically rather attach to business systems. So we speak to a SharePoint repository, for example, or we get REST calls from some, to us, opaque process that provides us with documents or messages. Or what we see in specialized cases, for example, in the contract area, is that we have to speak to contract lifecycle management systems.
Yeah,
so
like
what they actually use, what kind of database they use, is very often opaque to us. But we have those enterprise sort of connectors that we need to basically connect to the major enterprise systems. Yeah.
Got it. Okay, very good. I think I've more or less understood what you're doing. It's fascinating and it's very, very interesting. I love your story, and I also love the fact that you're doing this out of Vienna. You know, it's great to see something happening really at cutting edge in a different part of the. By the way, I love Vienna.
Yeah, me too. That's why I'm still here.
Well, Francisco, what is your email? Let's just a second. Let me cut the recording, and then I'm going to talk to you for 1 second. Just a moment.